Hello, folks. Let's talk about some analog layout guidelines for beginners. Okay. We've come across lots of scenarios wherein we have seen lots of engineers, basically the bachelor's guys, the masters, or some of the PhD guys, trying to do the layouts. So they do. I mean, we appreciate their effort, but then there are certain ways, certain thumb rules what one needs to follow before you start doing the layouts, which will in fact help them a lot when they do a proper layout. There is a certain way of doing certain things. So that's what we are trying to highlight in this session, which is basically for beginners or starters, whatever the guys who are trying to get their hands on the layout side. As well as we have seen lots of experienced engineers, say somewhere around 0 to 4, 0 to 5 years, wherein most of them they do the layouts, but then it is they don't follow a proper guidelines, proper thumb rule, what needs to be followed while you do the layouts, which will in fact help them to do their work better. So let's take one by one and try and figure out how we can formulate the things in a specific way which would help everybody. Okay. So before we jump in to doing the layouts, we need to observe the schematics very carefully. Okay. So for a layout guy, yes, you might be doing a layout job, but there are certain things what you have to observe in the schematics before you even jump onto doing the layouts. So let's take one by one over here. Okay. First thing here, let me just change the color of the pen here. Okay. You should have a top to bottom view of your complete design hierarchy. Say, for example, you're a person who is doing a fresh layout. You've got some modules of hierarchies like this. Okay. So now, as a layout engineer, you should have an idea about where is your module sitting. Whether it's a small module, what you're doing, whether it's a top level, what you're doing, or you're trying to support somebody, you need to have an idea of your whole module. Okay. So what I mean to say over here is, for example, you've got this bigger guy here. Say you're assigned this particular module. So you need to know whether you've been assigned this or you've been assigned a bigger module to do. Okay. And who is taking care of the top level. So this becomes very important for you to plan your module, to plan your floor plan, to plan your pins. Okay. So that's why, and also it is very important for you to know the signal flow. Okay. So let's go to the next slide now. Look at the block level modules and inspect the input pins and output pins. Okay, if you see here, each module has got certain set of input pins coming in here. Okay, these connections are going over here. Okay, and then certain pins are going over here, and certain connections are going over here, and this is your output. So if this is the module what you're trying to do the layout for, you need to understand where are the input pins coming from and where are the output pins going to, right? Thereby it will help you, okay, to do the internal floor plan of your module. And the other thing what you also should be looking for is you need to ask the person who is doing the next level module that where is my module sitting? Is it sitting somewhere in the corner? Okay, is it sitting somewhere here? You have observed the schematic, you know that these are the inputs coming in, these are the outputs going. So the next module which it is talking to, that is this one, for example, this guy here, right? Whether it is kept at the top side or at the bottom side of your actual layout. So that's what you want to figure out here. So if at all the next module which it is talking to is placed on the top side of this module, okay, so then you need to check from which side are my inputs coming. If they're coming from this side and the output is going here, there's no point in you having the pins on the left and right. So you should plan your floor plan in such a way that all the initial part of the circuitry takes the inputs from here and you have the outputs going to the top to the next module. All in all, what you're trying to do here is have the correct accessibility based on the signal connectivity. One thing to keep in mind here, always try to do a floor plan in such a way that the signal flows seamlessly. It should not go back, come back, take zigzag turns when you're doing a floor plan. Keep that in mind when you are doing a initial floor plan of your module. Okay, so the next point to look into is in your design to layout, first thing is to look for different power supplies. Okay, let me just clear this thing up and see what it is. Okay, so you need to look for different power supplies. Let me just erase this guy here. Okay, so now you see that there are different modules. In this section, there is only one power supply. Okay, every time it's not a must that you will be working with one power supply itself. Right? Every module, what you do, let me just change this, new discard. Okay, every time when you do it, just assume that this module is there. There is VDD1 or and here and there is VDD2. So you need to check in your module whether your module is having only one type of a power supply or it is using both. Based on that, you need to, it helps you do the floor plan of your uh, internals of your module. First thing, you have to always check whether my module is working on one power supply or more than one power supply. And you also need to check at the next level of the module that if I keep my modules on this side, how are you planning the power mesh at the top level? So, at the top level guy might have planned the power mesh wherein VDD2 is used only in this section. Okay, and rest of all is VDD1 over here. Okay, and only this guy here is VDD2. Let me just change the color. Only this portion is VDD2. So you need to be able to place your internal modules in this particular region wherever your module is being used. So certain things you should do it on your own. Certain things you should get clarity from the next level person who is doing the module. Okay. So that's done. Look for all the, now assuming that you're doing a analog module. Okay. So look for all the current mirrors and differential pairs and have clarity of the devices. So if you see here in this circuit here, there is a current mirror over here. Okay. There is a differential pair over here. Again, there is a current mirror over here. How do you, the easiest way how you figure out, how many uh, mirroring devices are there is you just look for a diode connected device first and you just highlight the gate net of it. So here it will clearly show you that wherever the gates are connected, all those devices are a part of the same current mirror. That's the easiest way to figure out what are all the current mirrors, mirroring devices a part of that particular current mirror. Okay, now you know that these are the devices which you have to match. This is a current mirror here, this is a differential pair over here. Now you also need to be very sure when you're doing the matching, just you need to zoom in. Sometimes when you look at the circuit, it looks, oh yeah, all these are current mirrors, differential pair. You will just start doing the floor plan of that and get going. But it's sometimes it's very much advisable that you zoom in properly and have a look at it, whether it's a single device, whether it's a multiple device, whether it's a multiple fingers are there, or whether it's a stacked device. Sometimes we tend to make some mistakes. We just look at the circuit, oh, this is such a tiny circuit, and you end up giving a schedule for your lead saying that, oh, this is just hardly 5, 6 transistors. I can do it off within a day. But when you actually generate the devices, you end up finding out there are hundreds of devices. You just panic and you just again just get into that panic state and mess up things for yourself. So the earlier you're cautious about assessing the assessing your module, the better for you. So say assume that you need to figure out whether this is a single device, whether it is a device with multiple fingers, or whether it is used in multiple values. Okay, or it is a stacked device. Stacked, I mean to say bunch of devices, say 14 devices together put as one large device. 14 or 12 devices, 16 devices, bunch of more number of devices considered as one transistor. Okay, stacked devices. And the other thing what you need to look for is what type of transistor it is. Ideally, we have similar type of transistors, but sometimes you never know. This will be SVT. This could be there could be another portion here which could be LVT. You never know. Okay, don't just go by assumption and try to share the guard rings, try to share the devices, and do you'll end up getting into a lot of LVS and DRC issues. Okay, that also you need to keep in mind. Okay, that's another thing to check. Okay, so another thing, the next point over here is just observe your schematic over here, whether the bulks of this are connected to what type of power supply. If it's a PMOS, then obviously it will be connected to the positive supply. Okay, that's the VDD, for example. If it's an NMOS, it is connecting to ground. Same thing over here, it is connected to ground because this is a differential pair made from a made using NMOSes. So, but there would be certain scenarios in which you would have something called as the floating well, wherein this particular bulk here is not connected to the supply, it is connected to the another terminal over here. This kind of transistors are called as hot well connections. The ones, the bulbs wherein which is connected to supplies are called as cold wells. The bulbs which are connected to any other net are called as hot wells. Sometimes in hurry you would just say, oh, there's a differential pair over here. Let me go and do the matching over here. And you will do all, put the dummies, everything. And again, you start getting LVS errors. Why? Because the bulks itself are very much different. On what basis did you put them in the same guard ring? Okay, so whenever you find a transistor wherein the bulk is connected to another net, this compulsorily requires a separate guard ring. Okay, because this is not, the bulk is not connected to the supply here, the bulk is connected to some other net. Okay, so you need to keep an eye on these things as well. Okay, so that's about this. So let's move to the next slide and try and see what's the next thing what you have to observe. Okay, so now look for any current ratings in your schematic. Okay, say here, for example, it's given 20 milliampere as the current which is taken by this certain transistors over here. So you need to be able to count how many transistors are there, how much current is going in each leg. You should be able to calculate what is the width of my source and drain terminal, width of the metal, I mean. Okay, what should be the width of the metal I should use so that it will be able to carry that much of current. EMIR calculation also needs to be done. Okay. Apart from whatever matching, say if you're doing a current mirror, the default is interdigitization. If it's a what do you call the differential pair, it is a common centroid. But in certain cases wherein the sensitivity is more, you need to check with, if at all the designer doesn't say, you need to ask questions to your designer. That, see, I'm doing this thing over here. You need to tell me how much, whether do I do a standard interdigitization or do you want me to do a common centroid matching? And keep in mind that you should always use dummies around it. Okay, and along with that you should also ask for some crucial nets. Okay, say for differential inputs or differential output nets, sometimes it requires the signals to be shielded. Okay, or whether the signals have to have less resistance. You need to ask, are there any crucial nets do I need to take care? And are there any specific resistance values I need to meet for specific nets? That you need to check with your designer. Ideally, if it's a standard thing, you go by a standard format. But if you see something complex in your design, it is very much important that you check for those nets with the designer. He or she would tell you, no, I need the resistance on this net to be not more than 50 ohm or 50 micro ohm, for example. Okay, so then you need to take necessary measures in your layout to ensure that this particular net, if it is traveling from point A to point B, should have that much of, should not go beyond that. Okay, and some nets might require shielding. Like it is try to, it's kind of dealing with your signal integrity or crosstalk issues. So you need to check with your designer, do I need to go for a sidewall shielding? Do I need to go for a coaxial shielding? or any other. Now, finally, any other specific. Now, obviously, all these things are very important for a beginner, but if you've already done some layouts, if you've got some idea about it, you don't have to ask all the questions, whatever I mentioned before. So some things come by practice, where we just say that, okay, fine, we go ahead. I know the module over here. You don't have to ask each and every question to the lead or the person who's assigning you the task. You can just observe, go in, just ask what is the module, top level module here, where is my module sitting, and where is the top level layout. So the more you explore on your own, the more you learn. And people don't like being asking questions again and again. Okay, what should I do for this pin? What should I do for this net? Where is this coming from? Now, it's not advisable. So you need to put some effort on your own. In fact, you will learn more when you try to explore things on your own. Okay, you figure out whichever module you are working on, and then see where is this module sitting in the hierarchy. Look for yourself where it is, and if there are some things which you don't understand, now I have already given you a list of things to observe and keep a check on before you start doing the layouts. And still, if at all you come across some things which you don't understand, which you feel that yes, you need inputs, then you go and ask the designer or the next person in charge. Okay, so here are some of the points which we've been talking about from the schematic point of view. So in the next video, we will see about what are the things a layout guy should do to start off the layouts. So all these things are the initial preparation for you before you start doing your layout.